class early today. My plan for today is to finish 1.5, and we are going to do only 3 or 4 questions from there. We're going to talk about LU factorization, and then I'm going to tell you what will be in the exam. I didn't make the exam yet, but what is my plan to put in the exam, I'm going to tell you that. And your exam will be March 9 on section 1.1 to 1.5. So that means next week we have 2 classes for new materials. So we are going to start chapter 2, but that will not be in the exam. That will be in the next exam. And also just a reminder that from February 18 to March 18, our Monday classes will be in person and Wednesday classes will be online for just a month. Okay, any question before we start? Any comments, concern, complaint? Nothing? Okay, so since you guys don't have anything to talk about, let's start the lecture. I already posted the review sheet long time ago, Florence. It's on Brightspace. Look at your Brightspace under content on the left panel. You'll see it says review sheet, and you see the review sheet there. Review sheet doesn't have any answer because all the questions or most of the questions, I just put them from our lectures. So if you want to see solution for anything, all you have to do is go to our lecture videos, which I posted on YouTube. And then the lectures are arranged lecture by lecture, like lecture 1, lecture 2. And then I also mentioned section name. So all you have to do is go to that section to get the answer for what you're looking for. Okay, so LU factorization. On our last class, we talked about a little bit about that. And we said when you have one matrix, sometimes it's better to break it down into 2 pieces. That will make our life easier. And we use it mostly, let me see here. It's useful. It's a very useful way of doing the elimination process. It will be particularly useful when you study computer methods for solving linear systems. And I also told you that in order to decompose your A matrix into 2 matrices, you only follow one allowed operation, which is the third operation. It means you multiply one row with a number, with a constant, and then add or subtract another row. So depending on the position you are trying to change, you are going to use that row and that column. So let's start this question. We have a matrix 369 row-wise, 152 row-wise, 4, -2, 5 row-wise. Our goal is to convert this into an upper matrix. Goal. And that upper matrix has the exact same column, exact same first row as the original one. So we'll have 3, 6, 9. And then since it's upper matrix, so we want to have 0 below this, 0 here. And then we don't know what we're going to get in this position, and this position. So our goal is to get rid of this 1, 4, -2 from this A matrix. In this process, whatever number you're going to multiply by, that will tell us our lower matrix. So this is our upper matrix. Now, let's start with the first one. We have 1 here. We want to put 0. And this position is 2, 1. So we are changing row number 2, column number 1. So the operation we're allowed to use is row 2 minus something row 1. So whatever row you are changing, you have to write this row down first. And whatever column you are changing, you're going to subtract that row from a constant by a constant multiplication. So we have row number 2 is 153, 152, and we are subtracting 3. So that means we need to divide this by 1/3. So we get row 2 is 152, and 1/3 of row 1 means divide row 2, row 1 by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3. And you're subtracting, so all this sign will change. So we get 0, 3, and -1. We can change our third row at the same time. We want to make this 0. And now this position is row number 3, column number 1. So we need to use row 3 minus some type of constant, row 1. Now, for this math, our row 3 is 4. Let me make it darker. Our row 3 is 4, -2, 5. And we have row 1 is 3, 6, 9. Now you have to decide what you need to multiply by here. So when you subtract, the answer will be 0. We have 4. We need to multiply 3 by something, so that when you subtract that product from 4, the answer will be 0. Any idea from anyone? 4/3, perfect. So if you multiply by 4/3, the 3 cancel out, and we have 4 minus 4, which is 0. That means we need to multiply 4/3 by here and multiply 4/3 by here. So we are doing 4/3 R1. So if you do the multiplication, 3 goes to 6 twice. So we have 4 times 2, 8. We are subtracting. So -8 minus 2 gives us -10. Here we have 3 goes to 9 3 times. So we have 12. 5 minus 12 gives us -7. So we have the same first row, 3, 6, 9. And our new second row is 0, 3, -1. New third row is 0, -10, -7. So we are happy we have zeros here. Now the only thing we need to change is this -10. We want this -10 to be 0. So we are changing this position is row number 3 and column number 2. So the allowed operation is row 3 minus something row 2. So let's see. Our row 3 is 0, -10, -7. Our row 2 is 0, 3, and -1. So we need to multiply something here so that when you subtract, the answer will be 0. So negative 10 and then times what? When you subtract, going to give it 0. Any suggestion? We have negative 10, and you need to subtract something times 3 so that the answer will be 0. The trick is this. Since we want to get rid of the 3, so we want to have a 3 on the denominator. So that cancel out. And now, since you want to cancel negative 10, so we need a positive 10. So in order to have a positive 10, you have to multiply by negative 10 so that negative and negative turn into positive. So we have negative 10, positive 10, the answer is 0. That means here we also need to multiply this by negative, negative. Basically, we are adding. What? Negative, we're subtracting. What? I'm lost. We are subtracting by negative 10 third. So basically, we are adding. So let me rewrite this. We have 0, negative 10, negative 7, and we are adding 0, positive 10 over 3 times 3, positive 10 over 3 times negative 1. So we get 0, 0, and here we have negative 7 minus 10 over 3. I feel like something is wrong. I did something wrong somewhere. So here, in order to combine, we have negative 21 minus 10 over 3. That gives us negative 31 over 3. Yeah, it definitely looks bad. So the new column, the new row, we got 3, 6, 9, 0, 3, negative 1, 0, 0, negative 31, 3. This is our U. Now for L, we already have the L. The characteristic or the outline for L is we have diagonal all 1, and we have these zeros, and to get rid of this position for our U matrix, we multiply by negative 1/3. So we are going to write positive 1/3 in this position. And then to get rid of this position, you know what? Let me write this down on the right page. Or let me make this smaller so I can fit everything. So our upper matrix is 3, 6, 9, 0, 3, negative 1, 0, 0, negative 31, 3. For lower matrix, it means we have 1, 0, 0, 1, 0, and then 1. So these are fixed. This is an unit lower matrix. That means we need to fill out this position, row 2, 1. Row 2, 1, we used this. Come on. We used negative 1/3 to get rid of that 2, 1 position. So we need to write positive 1/3 here. whatever number you used on the left side, on the U side, you have to use the opposite sign. Now to get to the 3-1 position, we used negative 4/3. So that means in this position, we are going to write positive 4/3. And then lastly, in 3-2 position, what did you do? We added 10/3. So we are going to write negative 10/3. And this is our lower matrix. Now, I'm doubtful about my answer because all this fraction looks scary. So I have to check whether I did it correctly or not. So in order to check, we can always multiply them back to see if we get the original matrix back or not. So A should be L times U. So our L is 1, 1/3, 4/3, 0, 1, negative 10/3, 0, 0, 1. Our upper matrix is 3, 0, 0, 6, 3, 0, 9, negative 1, negative 31, 3. Now let's see what happens when you multiply them. When you multiply, we take first row and multiply the first column. So everything cancels out, we get only 3. Then we multiply the second column. So in the second column, the 0, 0 will cancel this 3, 0. So we left it 1 times 6, which is 6. And then we multiply the third column. Oops. We multiply the third column. Again, in the third column, the 0, 0 will cancel the second and third entry. So you left it 1 times 9, which is 9. So this is, I hate this. This is our first row for A matrix. We are going to compare that with the real A matrix later. Now, second, we take the second row and we multiply the first column. So in the second row, we get 0, 0, 0, 0, cancel out. So we get 1/3 times 3. That gives us 1/3 of 3 is 1. Then we multiply the second column. And in the second column, we move 0 and 0. And we're left with 6, 1/3 of 6 plus 1 times 3, which is 3. So we get 2 plus 3, that gives us 5. And then we multiply our third column. So in this third column, only 0, cancel with this one. And then we left with 1/3 of 9 plus 1 times negative 1, which is negative 1. Now 1/3 of 3 is 3 minus 2, 3 minus 1, that gives us 2. So second row is 1, 5, 2. Do we have that? 1, 5, 2. So we have 1, 3, 6, 9, 1, 5, 2. So 2 rows we got correct. And now the last one. For the last one, we take the last column, so last row, and we multiply the first column. So here 0, 0 cancel with these two. We left with 4/3 of 6. Sorry, 4/3 of 3. 4/3 of 3. So 3, 3 cancel out, we get 4. Then when you multiply the second column, in the second column, this 0 cancel with this 1, and we're left with 4 third of 6 minus 10 third of 3. So 4 third times 6 minus 10 third times 3. 3 cancel out. Here we get 2. So we have 8 minus 10. It's negative 2. And lastly, we do the last column. And this last column, nothing cancel out. Oh, man. So we have 4 third of 9 plus 10 third of 1, and then minus 31 third. So 3 goes to 9 3 times. We get 12. And since we have the same denominator here, so minus 10 plus 10 minus 31 gives us minus 21. So when you combine this, we get negative 21 over 3, which is negative 7, and which is 5. So last column is, sorry, last row is 4, negative 2, 5. Yay, we got it. Cool. That means our L and U, they both are correct. Oh. Okay, who is lost? Anyone? I didn't have much space here, so I wrote everything in a little bit messy way. But in
Professor, I
your
have a
paper,
question.
go ahead.
So the question is like, just to kind of sum it up here is like, essentially every time we get rid of like a value so that it becomes 0, that um that value that we are multiplying or dividing by, that value is what goes into the L matrix, and then all the leading
Yes.
variables go into the U matrix, right? And then we could just
Yep.
multiply. Okay, okay. Preach, thank you.
No problem. Any other question from any of you? So in the exam, you have to do one of these. So you should practice a lot. Are you allowed to scientific calculator? Yes, scientific calculator. So all this work actually I'm doing manually. You don't have to do them manually. You can just use calculator. So you guys try one. Find the LU factorization for this. And let me take the attendance now. Okay? I give you the hint here. Anytime you're removing a position, you need to subtract that row minus something times the column row. So you have to remember the position's name. This position is 2, 1, row number 2, column number 1. This position is row number 3, column number 1. And this position is row number 3, column number 2. So these are the only 3 operations you have to do. Row 2 minus something row 1, row 3 minus something row 1, and then row 3 minus something row 2. Only 3 steps. So go ahead, enjoy. Let me take the attendance. Today is 225, right? Yeah, 225. Ahmed,
Here.
Crystal,
Here.
Christian,
Here.
Daniel, Eric,
Here.
Florence, Franklin, Dominguez, Gassen, Jalasi, Halil,
Here.
Imran, Jackie,
Here.
Jerry, Jonathan, Juan, Tavar, Julian,
Here.
Karma,
Here.
Kate, Kathy, Do, Man, Matthew, Melissa,
Here.
Muhammad,
Here.
Monata, Omar C, Omar D, Prabod,
Here.
Rakmanjan, Rayat,
Here.
Sadia Sattar, Sadia Sheikh, Samuel, Sam, Saraya,
Here.
Saima, Stephanie,
Here.
and lastly Valerie.
Here.
Great.
Professor, did you take my attendance?
Nope, I marked you absent because you did not respond.
I responded in text. And because I was
I
muted.
didn't see that. Okay. So Gassen present. Okay. I marked you present now. So absent is Franklin, Imran, Juan, Kate, Rakmanjan, and Sadia Sheikh. 1, 2, 3, 4, 5, 6. Okay. So, are you guys ready? Who would like to give me the first row operation to move 5, to change 5 into 0? So changing the position row to 1. Christelle, go ahead.
So what I did was I did row 2 minus 5 over 2 times row 1.
5 over 2 row 1. So our row 2 is 5, 9, 10. And row 1 is 2, 2, 3. And you multiply each of them by 5/2, -5/2, -5/2. So what did you get? This cancel out, you get 0 for the next one.
I got 4 and then 5/2.
And then 5/2. So we have 15/2 minus 15/2. So I get 20 minus 15. Is it positive or negative? Positive, right?
Yeah,
20
that's
is
what I got.
positive. Okay. Good job. Anyone else like to try row 3-1? Changing row 3-1 means changing 4 into 0. Any other volunteer? Okay, Crystal, go ahead.
Okay, so I did row 3 minus 2 times row 1.
2 times row 1. So we have row 1, row 3 minus 2 times row 1. So row 3 is 4, 1, row 3, right? 4, 1, and 2. And row 1 is 2, 2, 3. You multiplied by -2, -2, -2. So what do you get?
I got 0, -3, and -4.
-4. Okay, so let me write down this. We have 2, 2, 3. Our new second row is 0, 4, 5/2. New third row is 0, -3, -4. That means the only thing now I need to change is this -3 into 0. So this position is row number 3, column number 2. So what did you do?
I'm still working on that one, but
No problem, we can do it together.
yeah.
Row 3. So 0, -3, -4. And which row is supposed to use? Row 3 minus what? The hint is in the position.
Oh wait. Row 2.
Row 2.
Okay.
So row 2 is 0, 4, 5/2. We want to get 0 here. That means we need to add.
Yeah.
So -3 times, -3 plus what times 4?
We could put 4 in the denominator
Mm-hmm.
and then to get -3.
We have -3. -3 plus what will
Oh.
give you 0?
Oh, -3.
We have -3. If you have another -3, okay, yeah, -3 negative
Oh,
times
sorry.
positive. So you can simply
Yeah.
write +3.
Positive, yeah.
So 3/4 positive. So +3/4. So we get 0 here, 0 here, and then -4 times, sorry, -4 plus 15/8, right? 3 times 5, 15, 4 times 2, 8. So what do you get? -17/8, right?
Yeah.
Okay, good. So I don't have to verify. Thank you for verifying that for me. That means we are done. We found our U. 2, 2, 3, 0, 4, 5/2, 0, 0, -17/8. And that's going to give us our L matrix. So Ahmed, would you like to give me the L matrix?
Yeah, sure. It will be 1, 0, 0,
1, 0, 0,
5 over 2,
5 over
1,
2,
1, 0,
1, 0,
then 2,
2,
negative 3/4, and 1.
negative 3/4, and 1. Perfect. So every position we moved, first we moved that to one position using negative 5/2. So this position we're supposed to do positive 5/2. Next, in 3, 1 position, we use negative 2. So in this 3, 1 position, we have to use positive 2. Lastly, to change this negative 3/2 position, we use positive 3/4. So in this position, we're supposed to have negative 3/4. And then we can verify to see whether these are correct or not. So whoever tried, did you guys get the same matrix, same 2 matrices, or do I have something different than yours? If all of you have the same matrix, that means we are correct. But if you don't, then I have to verify. Same. Great, great. Anyone else tried? Ahmed, same. Valerie, same. Anyone else tried it? No? Okay, so that's how we find LU. And in the exam, I will require you to verify that, because otherwise you're going to lose all the points you try to earn by doing all these math. So in the exam, must verify. How do you verify? You multiply your L with the U, okay? Not U times L. Matrix multiplication is very sensitive. So you have to have left matrix, the lower matrix here, and upper matrix on the upper side, on the right side. Oh, I have the answer here. Cool. Let me check. 200, 240, 3/5, and then 17, whatever that is, 17/8. And then we have 100, 5/2, 102, negative 3/4. Yay, our answer is correct. Okay, any questions so far? Remember, guys, if you didn't understand anything, you should ask now, so that in the exam you feel comfortable and confident to do this. So was any step unclear to any of you? Do you want me to explain anything more in details? Nothing? Okay, so this is not the only way to find this decomposition. There is also another way we can find this decomposition, and that is using system of equations. So, for example, here, we have a matrix 301 row-wise, 611 row-wise, negative 310 row-wise. So we know this is L times U. And we know our L is an unique lower triangular matrix. That means these are fixed. So the only 3 unknowns are X, Y, Z. And we know our upper triangular matrix has these 3 things fixed. And most likely, I'm not sure is it always or not, but as far as I know, this thing is same as the first row of the original A. That means another 3 unknown we have is these 3, B, E, and C. So let me actually try this and see if it's true or not. So we have 3 unknowns here and we have 3 unknowns there. So what you're going to do, you're going to multiply L with U, and then you're going to get the right side of the equal sign from A. For example, let me write this down. We have 1, 0, 0, x 1, 0, y z 1. So these are lower matrix, and you're multiplying 3, 0, 1, 0, be 0, 0, c. So when you multiply, we get this row, this column, so 3. And our first element here is 3. So this is correct. Then we have an unknown in the second column. So when you multiply this, we get 1 times 0, b times 0, 0 times 0. So we don't have any b. Confusing. So we have 1 times 0 is 1. So 1 times 0 is 0, 0 times b is 0, and 0 times 0 is 0. So we have everything 0. And then we have the next one is here. We have another unknown. We have 1 times 1 is 1, plus the rest are 0. And that's the position here, 1. So basically we did nothing in the first row. So let me skip the first row. First row has all zeros, so practically it's useless. Let's go to the second row. So in the second row, we have few unknowns. Second row, first column, we have 3 times x, which is 3, plus 1 times 0, 0 times 0, nothing. So 3x is 6. That gives us our x is 2. And then we can go to the second row, second column. So here we have only one unknown b. B times 1 is b. And second row, second column. Second row, second column, we have this number. So b is 1. So we found our x and we found our b. Now let's go to the second row, third column. So second row, third column, we have 1 times x, which is x, plus e times 1, which is e. And second row, third column is this one. Second row, third column is this. We already know our x is 4. So that means e is 1 minus 4, which is negative 3. Did I make a mistake? The second matrix is the upper matrix. So this is U and this is L. We are multiplying LU. So we are working backward. Previously, we decomposed A and got the L and U. And here we got L and U first. And we fill out all the unknowns we're supposed to find. And then working backward, we are setting this is equals to 3, 0, 1, 6, 1, 1, negative 3, 1, 0. So every time you find a position by multiplying LU, you get the equal sign equal to that position from the A matrix. So we found one unknown in the lower matrix X, and we already found 2 unknown in the upper matrix U. That means now we need to know 2 unknowns in the lower matrix X, Y, Z, and 1 unknown C in the upper matrix. No problem. So let's go to our third row. So third row, first column, we have 3 times y, which is 3y, and then everything else get canceled out. So third row, first column. Third row, first column is here. So we set this equals to -3. That gives us our y is -1. So we found this unknown. Now let's go to the second row, third row, second column. Third row, second column, y and 1 cancel out, we get bz, b times z. So third row, second column. Third row, second column is 1. So b times z is 1. And we already know our b is 1 from before here. So that means z is 1. So we found this unknown. That means we need to know only one unknown, which is z. So you go to the third row, third column. Third row, third column. And the equation we get from here is 1 times y plus e times z plus c times 1. And third row, third column is 0. So our answer is 0 here. But you already know our y is -1. And we already know our e is -3. And you already know our z is +1. So when it's solved, we get -3 minus 1, -4 plus c is 0. So c is +4. So now we found all these unknown. So our upper matrix is 3, 0, 1, 0. Our b is 1. And our e is -3. Then we have 0, 0. Our c we just found is 4. So this is our upper matrix. And for lower matrix, we need to know x, y, z. So we have 1, 0, 0, 1, 0, 1. Our x is 2. Our y is -1 here. And our z is 1 here. So we found LU without doing row operation. We just use our system of equations. And now to verify, I don't have answer. To verify, let's multiply L with the U. Our L is 1, 2, -1, 0, 1, 1, 0, 0, 1. And our U is 3, 0, 0, 0, 1, 0, 1, -3, 4. So when you multiply row number 1, column number 1 gives us 3. Row number 1, column number 2 gives us 0. Row number 1, column number 3 gives us only 1. So we have 3, 0, 1. And then we go to the second row. Second row, column number 1, the 0, 0 cancel out. So we have 3 times 2, 6. Second row, second column, the 0, 0 cancel out. We left with 1 times 1, 1. Column number 3, 0 and 4 cancel out. So we get 2 times 1, 2. And then 3 times -1, 1 times -3, which is -3. That gives us -1. So our second row is 6, 1, -1. And now our third row, we have -1, 1 times this. So 0, 0 cancel out. We get 3 times -1, which is -3. Here, the 0, 0 cancel out. We left with the middle term 1. And lastly, oh man, nothing cancel out again. So we need to do math. 1 times -1 is -1. And then 1 times -3 is -3. 1 times 4 is +4. So we get 0 here. So let's see. We have 301, 301, 61. So we get -1, but this should be +1. And then we have -310, -310. So everything is correct except this one. So probably I made a mistake somewhere here. 2 times 1 is 2. 1 times -3 is -3. 2 minus 3 is -1. I made mistake somewhere. Erase this. But you got the idea, right? So you have to be careful. What mistake I made? What number is it? E? Yeah, my E is wrong. So we got the E from second row, third column. So X times 1 is X, plus 1 times E is E, and our number is 1. So you get the idea. Okay, I'm too lazy to check. But everything else is correct except this one. So somewhere I made a mistake on this column, 1, -3, 4. Okay, any question? So if you found decomposition is harder, you can use system of equations. And if you find system of equation is harder or confusing than decomposition. Personally, I like decomposition. To find the from A to UL is better than finding the other way around. Yeah. Okay, so with this, we are done with 1.5. So you have your homework. Question number 1, ABC. Question number 4, ABC. Question number 8, ACD. These are short questions. You don't have to do any math in these 3. And then the actual math is question number 10, CG. Question number 12, BC. So your homework due is next week, Monday midnight, which is March 2nd, I believe. March 2nd. Yeah, March 2nd. And then after 1 week from March 2nd, you're going to have your very first exam. So far you did section 1.1, 2, 3, 4, 5. All 5 sections are covered, and you're supposed to do homework for all 5 sections. I checked only 1.1. I'm in the process of checking the rest 4. So I'll check them little by little, and you have time. And I told you that I'm going to give you a review homework for exam 1, but I decided not to do it since I already have so many gradings to do. So instead, I'll just grade your actual homework a little bit carefully. So if I find any mistake that will be in the exam, I'll just comment on your work on Brightspace. Okay. Any question, comments, concern, complaint? No? Then let me tell you what I'm planning to put in the exam. I posted this review sheet on Brightspace. If you haven't seen it, please go to Brightspace and you'll see both document format and the PDF format. So first of all, I'm going to give a few true, false, yes, no, those type of question. You need to read the lecture notes to get your basic knowledge right. And then question number 1, maybe, not sure. Why am I ink is not working? Come on. Question number 1, maybe, not sure. If I have space. Then from question number 2, I'm going to give you 3. One is for unique solution, one is for infinite solution, and one is for no solution. So only for no solution, you write no solution. Besides that no solution, for unique or infinite, you do have to find what is your x, what is your y, and what is your z. You cannot just write infinite solution and stop. Nope. If you do that, you're going to get 0. Even for infinite solution, we have a formula for each variable. Which one is free variable and which one is not free variable, you have to indicate in the infinite solution. And for unique solution, you already know what is unique solution. So you have to find unique solution. For example, here we have a unique solution. Your z is 2, and then substitute this z in this equation to get your y, and then substitute y and z in this equation to get your x. So for unique solution, you do have to find x, y, z, probably using back substitution. For no solution, when we have all zeros on the left side of the bar, but a number on the right side, it's automatically no solution. So all you have to do is indicate that one row that tells us we have no solution, and then write no solution. For infinite solution, this one has infinite solution. So for infinite solution, here we have our z equals 3, and you substitute z equals 3 here. So you need to know what is x1 and what is x2. x2 here is free variable, and x1 will be in terms of x2. So you need to write what is x2, what is x1, and what is x3. For x2, it's itself, so it just indicates x2 is x2. So 3 of them, one for unique, one for no, and one for infinite solution. And then Gauss elimination or Gauss-Jordan elimination, one of them. I'm going to give you something easy, okay? But you have to figure out all the easy steps. Previously, I gave the easiest question, and then people made it so complicated. Please do not make things complicated. Every question I give in the exam, they're actually easy, so you can do them within your time frame, 1 hour, 15 minutes. If you find something difficult, that means something is wrong with your calculation. From my side, I gave you easy questions, so you can solve easily. And then decide whether matrix multiplication is possible or not. These are fun questions. So basically, you're going to get 3 points. So my plan is to give a few. Why my ink is disturbing? Come on. How about this one? No, same. Okay, so a few of them, okay? You don't have to do any math. All you have to do is figure out whether matrix multiplication is possible or not. If possible, then what's the dimension of the product? For example, here this is 3 by 2. So you're going to write the dimension for each one, 3 by 2. And then we have 2 by 3, and then 3 by 2. So first we do row, and then we do column. So 2 row, 3 column, and then 3 row, 2 column. Matrix multiplication is possible because column and row are same. So you're going to write product is 2 by 2. Whatever you left with the row and column, that's the product. What did you write? My bad, I just talking to me. No, I was talking as a class. Oh, are you going to be lenient with partial credit? Most of the question will be 2 points or 3 points. So if you get one mistake, I'm going to take off 1 point. If you get more mistake, I'm going to take off 2 points. if it's if it's 3 points question, then depending on if you do many mistakes, you get 1 point. If you do only one mistake, you get 2 points. And then whatever is not possible, you simply write the dimension and write not possible. That's all you have to do. So no math is needed. These are easy points. So I'm going to give you a few so that you can earn points easily. And here you don't have to find any inverse. So no inverse. You just have to convert this into matrix equation like AX equals B. B is your right side. A is all the coefficients. And X is the variable X, Y, Z. My ink is not working. Come on. Well, probably because it's one-sided. That's why. And then you find a matrix. So this is your step 1, what you're going to do. And step 2, you're going to tell me whether A inverse may exist or not. So A inverse may exist if your A is a square matrix, n by n. If you have an n by n matrix, you can write A inverse may exist. So we can solve the system of equations using A inverse. May, okay? Just because it's a square, it doesn't guarantee you have an inverse. So you have to indicate it may, A inverse may exist. So we may be able to solve the system of equations. But for this one, we have 2 by 3. It's not a square matrix. A is 2 by 3. So you say A inverse doesn't exist. So solving this matrix equation is not possible. So you're not going to do any math. Convert into A, X, and B matrix, and then tell me whether you can solve this matrix using inverse or not. Combining question 6 and 7, I'm going to give 1 or 2. So here you need to know how to find power of a matrix, how to find transpose of a matrix. Probably I'm going to ask this as yes, no, true, false question type. So all this information, I'm going to ask 1 or 2. It depends. You already know what is 2 by 2, 3 by 3, 4 by 4 identity matrix. So I'm not going to ask these 2, but I'm going to ask both A and B. One will be directed and one will be undirected matrix. Sorry, directed and undirected graph. So here you're not going to do any math. You just observe your path from one point to another point, and you tell me how many ways you can go from one point to another point. For example, here we have A, B, C, D, A, B, C, D. So it's a matrix. You have to write as a matrix format. From A to A, you cannot go, so it's 0. From A to B, you can go 1 way, 2 way, 3 ways. There are 3 ways you can go from A to B, so you write 3 here. And then from A to C, you cannot have any direct path, so A to C is 0. From A to D, you have 1 path, 2 paths. There are 2 ways you can go, so you write 2. And you always walk from your left side to your right side. So B to A, it's undirected graph, so you have 3 ways. B to B, there is no loop, so it's 0. B to C, there is no direct path, 0. And B to D, there is only 1 path, so 1. So that's what you have to do. Observe how many ways you can go from one position to another position, and then record them in a matrix format. So 2 of them, okay? And then from here, 1 solving system equations. Sorry, 1 solving matrix equation and 1 finding LU factorization. So these 2 will be big. Especially this one is big. You need to take, it will take your time. So make sure you practice a lot so that in the exam, you can solve it easily. And I'm going to give 3 by 3, not 2 by 2. So these two, you need more time. The most time you need is this one. So I'll suggest do this one at the end because it will take your most time. And then for the rest, they are simple questions. So do the simple questions first and then do the hardest one, which is row echelon form or reduced row echelon form. Okay. Any question, comments, concern, complaint, anything? What are some examples of the true-false question? One example. Is this true? AB equals BA. True or false? And then is this true? AE equals EA. Is the elementary matrix true or false? So AB equals BA is false because matrix multiplication is not commutative. However, elementary matrix is an option, is an exception. So for elementary matrix, this is true. And then what else I can ask? A inverse exists for any A. True or false? What do you think? Regardless of your dimension for your A, you can always have A inverse. Fill in the blank. Only what matrix have inverse? So obviously the first one is wrong. Not every matrix has an inverse. Only square matrix have an inverse. See? So these are basic knowledges you should know for the materials in this class. Nothing hard, but if you read through all the slides I posted on Bytespace, you'll have some idea. No problem. So remember, next two class, chapter 2, that will not be in the exam. And I already told you what will be in the exam, what section, what to expect, and how many questions. So the rest is up to you guys. Study smart. Yep, I hope so, Rayat. Do not let me down. Try your best, guys. Thank you, Karma. And remember, all the questions are easy, okay? So if you find something hard, that means something is wrong with your solution. What? I didn't hear you guys. What did you say?
Professor, I have a question. Since your exam is on Monday, will you still hold office hours on that Monday?
Yes, I'll
Like
be
before the exam?
Before the exam, yeah, I will be in our office.
And then I also have another question. I was wondering, just like to double check, did you get my attendance? Because I wasn't sure if you called my name out before to list
Let me
out people
see.
who weren't here.
Kate. Yep, I marked you present.
Okay, thank you.
No problem.
Thank you, Professor.
Bye, Eric. Oh, Eric, question?
Hello. Just to confirm, the exam is on March 9th, right?
Yes.
Okay, thank you.
No problem. So goodbye, everyone. Be safe. You too. Bye-bye. See you next week, Monday. Most likely in person if there isn't another storm. So bye.
Hi, Professor.